Hey, hi everyone. Welcome to the Maruti classes. Today we are continuing our previous class of chapter 1 rational number of class 8. In a real class, we have completed our theoretical portion of the rational number. We have learned the properties of the rational number and also try to understand the concept of the rational number. Now in this class we have to solve some examples, then we are able to complete this chapter. So now we have to move forward with examples. Let I am briefing the concept of previous class, then you will better understand if you are not revising in your home. Yes, I am also teach you in the previous class that the properties of rational number as the closure property, your commutative property, your associative property of closure, distributive property, zero property, property of zero, rule of one. Have you remember this? Have you learned this? Have you revised this in your home? If yes, then you are in the better position. Otherwise, you have to do work hard. Otherwise, you will face some serious consequences in the further classes or in case of examination. Now we have to see some example as this were given in your notebook. The examples were given after the properties of your rational number, just like the first property is closure property. As I am said you in the previous class, this closure property were uh, accepted or compatible. This closure property is compatible for addition and multiplication, not for subtraction and division, as here also mentioned. So this is proof in case of rational number also by giving them to the examples. I am teach you in the pen and paper format, then you will better understand what I am trying to say. Yes, here, yes, here you can able to see that in case of addition, in the closure property of rational number, in case of addition, here two rational numbers were added. This example is given in your book, textbook, so don't worry. And here when we add these two terms, here we have to take LCM of denominator, and after solving it we are getting the result of minus 19 upon 56, as you can able to see here in the notebook. The same example, here also the result is minus 19 upon 56. So they were just trying to teach you, or that the learner have the better understanding capability, that what the exactly the property of closure try to teach us, try to so we have to understand it for the case of addition, for the case of subtraction, case of multiplication, and also for the case of division. Now here the second property is commutative property. Here, as we know that we have to change the position, 0 plus 7, 7 plus 0. Similarly, this a plus b equal to b plus a, we have to prove these in case of rational number also. Minus 2 by 3 plus 5 by 7 and 5 by 7 minus 2 by 3. Is the result is in both the cases are same? Yes, the result is both the cases are same for case of addition and multiplication, but the result is not same for the case of subtraction and division. When you solve it, the result will not be the same for the case of subtraction and division. It is only be the same for addition and multiplication. For case of associative, here the group of numbers were play the game. Here also the addition and multiplication are compatible for this property, but not the subtraction and division. These were also given example for case of rational number. They were adding these three rational numbers, and here the places of this rational number are interchanged, and they were trying to prove them. So here, yes, the result will be ultimately same. So uh, nothing is much more difficult or tricky portion here to worry about. Here, all these are the examples for the associative property. For the case of 0, they were adding the value of 0, multiplying the value of 0, dividing the value of 0, and subtracting the value of 0. Some case property change, result change, some case result unchanged. When you solve just for one, then you will better understand this. Look at the distributive property here. Here look at minus 3 by 4. The value minus 3 by 4 multiplied by this curly bracket, and inside the curly bracket two datas are given and there is a addition between them. So in distributive property, the minus 3 by 4 firstly multiply by 2 by 3, then minus 3 by 4 secondly multiply by minus 5 by 6, and ultimately the result will come. These were the two examples of this. Here you better understand that how they are trying to teach in the trying to say in the property portion, and how this property portion were replicated here in the example portion. Here there is an exercise. Here three questions are given, and they were trying to ask some questions that which property are used in these questions. So when we see the first question, minus 4 by 5 cross 1 is equal to 1 cross minus 4 by 5 is equal to minus 4 by 5. So when we multiply any digit with 1, then the result will be remain the same. Either multiply 1 earlier or after, the result will be the same. So here which property we are using? Here two properties are used. Firstly, the property of 1 is used. Secondly, the property of commutativity is also used. Commutativity property is also used. AB is equal to BA. Okay, understand guys? Now the second question, in the second question here also AB is equals to BA. So the commutative property is used. In the third question here, here also the property of 1 and associative property both are used. Tell what property allow you to compute 1 by 3 cross 6 cross 4 by 3 as 1 by 3 cross 6 cross 4 by 3. Here you can simply understand this property just by learning the property at in a at once. Here associative property is used. Here the brackets were given in the second and third term, and in the second case the bracket were used in the first and second term. So here the associative property is used. The product of two rational number is always a rational number. Okay, so hopefully this example portion were better understand by you, and in further class we are starting the another chapter, moving forward to your maths journey. Thank you.